Hello, and welcome back to yet another retro channel. Today we're going to see how far we can get with the Apple II Plus. If you haven't watched the unboxing video for this, I will put a link for it up in the corner, and you can pop over there and watch that. But if you didn't watch it, what we have here is an Apple II Plus. Now, this is my first ever Apple product. There's an explanation for that, or at least a discussion of that in the unboxing video, and why I'm just now cutting my teeth on Apple. But this machine I picked up on eBay as parts of repair. It said untested, won't power on. Now, in my view, attempting to power it on is at least a test. So saying untested is a little disingenuous, but we'll cross that bridge when we come to it. This machine has the wrong cover on it. If you look, you'll see that it says it's an Apple IIe on the cover. That's not actually the case. By the model number on the back, it is definitely an Apple II Plus, sold originally as a 48K machine. So I've been doing some shopping, and I've got some things that we're going to look at. First of all, the cover. The big issue here, that it says it's an Apple IIe and it's not. So I went on eBay and I found this, a proper Apple II Plus cover, and I have reattached the attachments inside here. Let's back off again and I'll show you. These have these well, they're similar to Velcro, but they're not Velcro. They're plastic with small little pegs with little balls at the top, and they connect into the same thing basically down here. I had to reattach this one. These were attached, but this one was loose. I took it off the other cover, and actually I need to reattach this one again. I need to pull this one off and reattach it because it's sitting up a little high, and as a result, when you snap it into place, it sits up a little bit. So I need to pop that one back off and reattach it later. So there's that. One thing we got for it. We're going to do a teardown today, and we're going to take this thing apart and clean it. Clean the case, clean the motherboard is dusty and grimy. Obviously, we're pulling everything out of here, pulling the keyboard off. We do still have a missing key, however. Another thing I've purchased, I got a set of keys for the Datanetics keyboard, and I now have the right key to replace that with. However, first I need to see if I can replace the key stem in the switch. I also picked up this. This is, I believe it was called an S Drive 2, and it is a floppy drive emulator for the Apple II series. It emulates the Disk 2. So when we get this thing running, I'll be able to load some software off of this, hopefully. But to do that, I'm going to need a cable, and since I don't have any Disk 2s, I don't have any cables, so I bought the 20-pin IDC connectors that are necessary to build the cable, and I've got some ribbon cable. Since I was told that this thing won't power up or won't turn on, we are going to be doing a teardown of the power supply, and that's going to be a job because these things have rivets holding them together, so I'll have to drill out those rivets to get this thing open. And I'm not the best with power supplies, with analog electronics or power supplies, so I'll be lucky if I can get this back working again. On the off chance that I can't, I have also picked up this. This is called a Pico RC, and it's a device that I'm going to have to assemble. All the parts are in there. It came as a kit, and these are available for several vintage machines. And what they are is a small board that adapts a Pico ATX power supply, which is what this is, a small ATX power supply with the 24-pin ATX power supply to be used on retro machines. And this one is specific to the Apple II, II Plus, and IIe. So it provides the right cabling and the right power rails to run one of these. If I can't get this power supply repaired, I will use this to power the machine. I've also been doing a little research into the cards that are in here. As I said initially, I believe this to be a language card, and that is the case. This is the language card, and what this does is it takes a 48K machine, adds an additional 16K of RAM for bringing the machine up to 64K, and it also allows the Apple II to boot from a floppy disk. And as I said before, this is the floppy drive controller. Now this is specific to Apple. It uses the 20-pin cable, and it's made to work with the Disk 2. There are obviously other floppy cards available. The Lyran card, I think, is one of them, and a few others, but this is the original Apple drive controller. So that's the cards that we have in here. We also had this card, which I'm probably not going to be putting back. This is a buffered printer driver. So this cable goes from here to a Centronics parallel connection that would go to a parallel printer. I don't have a parallel printer. I'm probably not going to have one. And, I'm not looking for one. It's almost impossible to get ribbons for them these days, so we won't be actually trying to do that. So that card probably won't go back in. Now, what we're going to do is go ahead and tear this down. I want to show you something real quick. The Apple II family weren't originally designed with RF output. At the time, in 1977, when the Apple II was designed and released, the FCC was cracking down on RF interference from computers. And since Apple didn't want to have to go through the testing process to be approved, when they released the Apple II and the II Plus, they didn't put an RF modulator in. This is an aftermarket product that they wanted you to use if you wanted to hook it up to a regular television. It was originally designed with composite output. So it was designed to go to a dedicated monitor. It was one of the first computers that was designed that way. When the Holy Trinity were released, the TRS-80 microcomputer system, later to be called the Model 1, the PET, the Commodore PET, and the Apple II, the TRS-80 microcomputer system came with a dedicated monitor. The PET came with a built-in monitor, and the Apple II, they wanted you to buy a separate monitor, but they wanted to they designed it for a monitor. And if you wanted to hook to a regular television, you had to get this adapter and install it. So that's what you see there is the RF modulator add-on board for RF output. So what we're going to do now is tear this down, get everything apart so I can clean the case, clean the motherboard, and begin work on the power supply. There are screws on the bottom that attach the bottom of the computer to the shell, so I'm going to have to remove those. Each of these screws does have a lock washer, so I'll have to make sure to get those back on there when I put this back together. These 4 screws attach the power supply. There's the power supply. Oh, well, you look at that. Someone's been in this already. They have already drilled out the rivets. So I'm not going to need to do that. It'll be easier to get into this than I had thought. Now, odds are the power supply isn't working, but we'll take a look at it. It's probably got, well, since it's been dug into before, it may or may not have Rifa caps in there. If it has Rifas, we'll be replacing those and then checking this thing out to see if it's working and see if we can get it working if not. Now, I think we are ready. Well, there's something else still holding it together. Let's see. Maybe this screw right here. Yeah. Oh, let's see, there's a standoff in here that's turning with the screw, so I'll use some pliers to get hold of that. There we go. That's why the screw wasn't coming out. Okay. So now what's holding this together? Nothing? There is the top shell connector for the RF modulator and keyboard connector. Now, we have a compression post and compression post up here. Okay, there is the motherboard removed from the bottom of the case. I did make one small mistake, or have one small failure. This standoff, compression standoff, I couldn't reach it from underneath the board to hold on to it. I tried holding on to it with the compression, the nub that was on the top, but when I did, it snapped off. So I lost this one. I may be able to find a replacement, I don't know, or we'll just use that as we may just put it back on as a standoff and not have the hold down at the top. It has all the screws and the other hold downs, so it shouldn't be an issue to have lost one of them. Now, the keyboard needs to come out, and the RF modulator. And this is on with sticky tape, so I will use a spudger, and we'll see if some IPA helps pull that off. There we go. There's the RF modulator. It was a small cut on my thumb, and I just got alcohol in it. That's not much fun. Now let's pull the keyboard out. And there is the keyboard. It's quite dirty underneath, dusty, but we're going to have to pull that apart so that we can get at the key switches and see about fixing this one. We have a manufacture date of November 10th, 1981. So this machine was built in 81. The Apple II was released in June of 79, so this is not one of the earliest models, but still a pretty early computer. Now, the case, the bottom, and the case bottom, the cover, the new cover, and the motherboard will be going for a wash. This, I'm not sure what this is. We'll have to figure that out at some point, but I believe this was connected here. There's the motherboard. There's your 6502 CPU, your expansion slots. Most of the memory is down here. One memory chip has been removed so that you can connect. The language card has a small ribbon cable with a chip adapter at the end of it, and then you move that chip onto the language card, and that goes with the other 16K that's on there, and that connects the memory to the bus. Buses, the address and data bus. And everything on here looks to be relatively intact. Obviously, I won't know until we can power up whether any or all of these chips are bad. We'll have to find out. But this will go for a wash as well. Just warm soapy water and a soft bristled brush. And then I like to air dry them with an air compressor, and then let them dry for a minimum of 24 hours before applying any power to them. So that's all going to go for cleaning. And in the meantime, we will take a look at the power supply. Like I said, someone has been in here, so it's not virgin. Oh, and a word of warning, if you're not comfortable working around power supplies, you might want to get some assistance from someone who does know. I know just enough to keep myself safe, but like I said, I'm not great with the electronics of power supplies. You have, if you're plugged in, you obviously have mains voltage exposed, but there are many capacitors in here that can hold a charge long after the power is no longer connected. So if you're not familiar with and confident in your abilities here, then it's best to either get assistance or get someone else to do the work, because you can shock yourself. You could even kill yourself. For instance, that was a mistake. Should have used a plastic spudger to do that. Okay, what have we got? We do definitely have one Rifa cap there, down here. All the other caps, I'm not seeing any that are bulging right off the bat. We can check the fuse real quick with my multimeter in continuity mode. We'll check the fuse. Actually, why don't we get this board out of here? It'll be easier and safer to do it that way. Right tool for the right job, eh? Board is loose. I've just got to get these. Wow. There is a right tool for this. I don't have one. I'm going to need to see about getting some. I'm gonna have to see about getting some pliers or something to help me get that loose. Okay, let's see if these pliers help. That did the job. Cannot seem to get that solder on the live and neutral posts to melt, no matter what I do. So that'll be interesting reconnecting that. But for now, let us check the fuse. Fuse is good. We do have a 0.1 microfarad X cap Rifa right in here. We need to pull and replace. don't know if you'll be able to see this. Well, you won't be able to see it. It's a Rifa branded cap. It is starting to crack, but it's actually still in pretty good shape. But we're going to replace it anyway. There's our Rifa replaced. Like I said, I don't see any other bulging or leaking. Starter cap looks good. Okay. I'm pretty confident that this thing is not going to go boom. Relatively confident anyway. So I'm ready to give it a test. And wall power. Sure, nothing's shorting. Multimeter on. It should be connected to the plus 5 volt line. That's the 12 volt line. It's a bit high. This should be plus 5 then. Also a bit high. Minus 5 and minus 12. Those are a bit lowish, but they are there, and this is an older power supply, and it may behave differently under a proper load. So I am actually ready to put this back together then and say that that is going to be okay. Okay, that is the power supply service. That will work. We'll put it back in to the computer. Won't need the Pico RC. So I will take the case and the motherboard and I will wash them tomorrow. It's getting a little late, so I'm going to call it a night. And we'll be back with more in the morning. Okay, so now that we've got the power supply addressed and I've got the motherboard washed, I've got the case washed, the motherboard is drying. It'll take another, I like to give it at least 24 hours. It's been, I don't know, 6 hours or so. So it's got another day to dry before we can actually attempt to apply power to it. It's time to address the keyboard. Now, I believe that I've actually made a mistake with the keyboard. I think, based on my research, that there may have been two types of Datanetics key switches used on these keyboards, and this may be the other type. One type, as you can see, if you can see, this type of keycap, the type of key stem rather, the type of key stem that I actually found to 3D print, the actual connection, the little cross, is at an angle. So the key stem would sit vertically, and then the top is at an angle for the key to be attached to. This appears to be the other type. Now, there is there was also an Alps SKCC keyboard for these things, and this doesn't appear to be that either, but it does appear that it might be the other Datanetics. So I'm not sure if the key switches, I'm pretty sure the key stem that I printed won't work. And I have spoken to a gentleman on the internet. He has an eBay store where he sells Apple II parts, and I'm going to put a link to that in the description below so you can go visit him. He has a lot of good stuff for Apple IIs. He is the one who sold me the keycaps for these, but he was also going to send me some key switches to see about replacing this one, as he tells me that it is ridiculously hard to open a Datanetics key switch to replace a key stem. Very nice guy. I believe his name is Larry Pell, the great Larry Pell. Very generous, very helpful gentleman who has provided me some assistance getting this keyboard back up. So anyway, I think I might have made a mistake in the type of switch. We'll look into that later. For the time being, I'm going to go ahead and remove the keycaps so that they can be cleaned. The reset is a special case. It's the only key that has its own separate spring. Apple apparently wanted to make the reset key harder to press so that you didn't accidentally wipe out your work while you were typing in a program or some such. So that has an extra spring to make it stiffer to press. So, but the rest of the keys we will just go ahead and pull with the key puller. I have already taken photos of the keyboard so that I'll be able to put these back in the correct order. I am being very delicate with these and pulling straight up on them so that I don't risk snapping any more of the key stems. Okay, the spacebar, as usual, will have a stabilizer that needs to be dealt with, and a spring. Actually, no, there is no stabilizer. Let's see what we've got here. Has its own special spring. has these that effectively work as the stabilizer. Okay, now to further disassemble the keyboard, you probably need to address these two standoffs slash expansion posts. Let's see if we can get them disconnected or pulled out. There's a connector in here, a header connector, that is also fighting me in pulling this out. Okay, I've got the board loose from those posts. Now I just need to get that connector carefully disconnected. Don't want to break anything here. Okay, this will be the keyboard encoder board, so this will get a little clean. The socket for the header pins will get some deoxit before the end. And now we're going to remove all of these little itty bitty screws. Hopefully this will allow me to remove the key switch circuit board, and then when I get the proper switch, it will allow me to put it to install it. Yep. I was kind of hoping that these four along the strengthening bar didn't have to be removed, but it appears they do. The purpose of that bar would be to keep the keyboard PCB from warping with use. As you type, you'd be putting pressure through the center of the board, and you could warp it, so they added this strengthening bar, I'm sure, to keep it from warping, bending, and or breaking. Oh boy. So this PCB has a thin plastic membrane over it with holes exposing the contact points. That needs to be cleaned. And then each of the key switches, different than I expected. Here is the stabilizer for the space bar. You should be able to remove that now. And that would have dropped these two little connectors through. The key that we need to worry about is this one. Do not like this open exposed. These are not the kind of key switches I expected at all. Looks like these are integrated with this chassis. I've never seen a keyboard like it. I understand how it works, but wow. As with the PCB attached, they press down on these, and then the key switch itself pushes up and makes, I don't know if you can see these really tiny little contacts here, make contact with the contacts on the PCB. I have to be very delicate because those are tiny parts and a thin metal and could easily be bent and cause this keyboard not to work at all. Whew. These are neither Datanetics nor Alps. These are some kind of custom-built keyboards. I wasn't expecting this at all. Well, those are held in place, so there's nothing stopping me from giving this a good clean. At least I can do that much. I just clean the PCB with IPA. I'm also going to clean the membrane with the same stuff. Let that dry. And now without further disassembly, which I don't think would be particularly safe to do, I'm not sure there's anything more I can do for this keyboard. So okay, this is by far the most fiddly keyboard I have ever worked on. This is actually called, I've done some research, this is called the ITT Snap Action Array keyboard. It was selected to provide an RFI compliant keyboard. It was made by the Keyboard Company. The Level 2 Service Reference Manual refers to the module as the Contact Array Keyboard. This thing is kind of a nightmare. It does not have individual self-contained key switches. It has an array of switches with what I would call, and I don't know if this is the right term or not, a dual leaf spring arrangement, a copper leaf spring and an aluminum one. And when the key is pressed, the aluminum one makes contact with contacts on the PCB and completes the circuit for the array. I don't know what the purpose of this keyboard was. Like I said, the documentation I found said it was for RFI compliance, radio frequency interference compliance. I don't think they're very common. I just got lucky enough to get one. And my only hope of fixing the shift key is if I can model and print one of these key stems. I can't find any sales anywhere on eBay or anywhere else for these key stems. I didn't see anything in the way of STL files on Thingiverse or anywhere else. So if I'm going to do this, I'm going to have to model it myself. So this key, as I said, this key stem, the only chance I have of repairing this keyboard is to 3D model and print a replacement for this broken key stem. Now, if you can see on the keyboard itself, those have a crosshatch on the top. So I would need to design this plus the crosshatch on top to attach to a key stem, or to a keycap. Otherwise, I need to find myself a replacement keyboard for this machine. So let me go ahead. I was going to wash the keys, but until I know for sure that I'm going to be able to fix this keyboard, I am just going to put it back together and leave it as is. I did take the precaution. I did take the precaution of taking a picture of the keyboard so I know where everything goes back. And we'll do these. I suppose we can do the space bar first. It has its own special spring. There's the space bar. And now the rest of the keys. So we'll do a little video montage for you. Reset also has its own separate spring. Let's see. Okay, there's the keyboard. Now the encoder board, I washed it along with the disk controller and the language card, and they are drying, so I can't put that back on at the moment, which means we are actually done for today. There's nothing more we can do at the moment for the Apple II Plus, so we will leave it there. Thank you for watching. I hope you enjoyed it, and if you did, please leave me a thumbs up, a like. I'd appreciate that. Leave a comment down below. That helps the channel. If you haven't already, please subscribe. I'm doing well on watched hours, but I do need subscribers. So please, if you don't mind, hit subscribe. It doesn't cost you anything. It won't even pester you if you don't hit the notification bell. If you do want to get notifications, click the reminder bell and you'll get a notification every time I post a new video. Share this with your friends, with your social media. I'd appreciate that. Get that out there to as many people as possible. Let's see. Be sure to check out my friends in the YouTube Retro Repairers group. We're actually expanding the group. We've added a new member. So right now, the membership stands at myself, 8-Bit Retro Refix, Steve, Captain Commodore Lee, Joseph from Joseph Retro Bits, Neil from Retro For You, Peter from 8-Bits in the Basement, and our newest addition is Duncan from Retro Crazy. So be sure to check out their channels. Their links will be in the description below. A big thank you to my Patreon supporters. Their names are flashing up on the screen as we speak. And we'll be back with you in the next week or so with another video. Will probably be a midweek palette cleanser. This machine, obviously the keyboard is going to be an issue, but before we can get past that, we'll have to work on the electronics. Now, as I said, this machine was sold to me as not working for parts or repair, won't turn on. Well, since the power supply has been repaired, now we should have power, but that may mean, but if the power supply wasn't the problem in the first place, which it didn't look like it had any issues, the Rifa cap had not exploded, or at least it hadn't visibly exploded. There was no residue left behind. And if that's the case and the power supply was good, that would imply that we have an electronic problem, and we'll need to sort that out. Several months ago, after seeing Adrian Black use one, I ordered a Romulator, which is a RAM-ROM replacement module for 6502 based computers. I've never built it because I haven't had need for it. So since this is a 6502 based computer and we may have a need for such a thing, I will be building that up and learning to program it. So we may do a midweek palette cleanser on that, and then we will probably be checking out something for the Commodore 64 coming up. Not a repair, but a device I'd like to try out with it, something I ordered online. And then we'll probably get back onto the Apple. Hopefully we will have some solutions for the keyboard. Like I said, if I can 3D print, if I can model and 3D print one of these. I've never tried to do that. I've only modeled some very macro scale things. This is kind of micro scale. So I'm going to have to learn how to do that. This keyboard, like I said, very fiddly to work with. So until next time, everybody have a great week and stay healthy, stay safe, and we'll see you next time. Thanks. Bye.